Welcome to the presentation based on the research called Using Fuzzy Logic in the Research of the Data Visualization Process in Infographics, prepared by Oleksandr Tymchenko, Orest, Khamula, Olha, Sosnovska, Svitlana, Vasiuta, Olha, Lukovska, and Solomiya, Dorosh. The contents are as follows. It is a well-known fact that the key way of obtaining information about the world is through vision. Perceived information allows to memorize information faster and accordingly to increase labor productivity. Information presented in the form of pictures, diagrams, or in any other presentation of infographics is even better perceived and memorized. This is due to the fact that the information presented in the form of infographics allows to better visualize certain details and draw attention to specific information rather than text. Usually, data visualization covers large amounts of information and condenses it. Another purpose of visualization is that it makes the perception of complex information more accessible and allows the creation of parties in the comparison of quantities. A crucial task of visualization is its persuasiveness. Therefore, distortion of the presented information should be avoided. When creating a visualization, it is important to consider the effectiveness of the data presented, what is worth sharing, and presenting it in a way that engages the user. The next step of this process is choosing the method of creating the visualization itself, which will convey specific information. Therefore, the study of various visualization techniques today is quite an essential issue and deserves the attention of researchers. Since the data visualization process is described by factors that are difficult to represent in the form of specific mathematical units, it is advisable to use fuzzy logic to clarify the accuracy of the results. It became necessary to use a mathematical tool with the help of which ambiguous expert statements would be translated into the language of clear mathematical formulas. As research shows, the usage of fuzzy logic is a convenient solution as it provides an opportunity to operate the fuzzy input data. In general, fuzzy logic uses linguistic variables with the help of explicit rules. Specification is the basis of the use of fuzzy logic. Its task is to transform the initial data into a set that would correspond to the terms of the linguistic variable. These data can be described by one or several terms. The degree of their correspondence to the term is given as the degree of membership on a fuzzy set. For calculations, fuzzy logical equations and a knowledge base are used. The knowledge base is built according to the expert data that are based on a fuzzy linguistic rules with the condition if, then. Accordingly, the operation that involves mapping the obtained numerical results of the calculation is called diffusification. Moreover, these numerical results may have different units of measurement. Fuzzy sets and linguistic variables are the basis of any fuzzy logic, which in turn are based on membership functions constructed using a set of terms and linguistic terms of the factors under study. The main values of a linguistic variable are words and phrases in natural or formal expressions. Of course, the data presented in the form of numbers are more precise than the data presented in words, regarding which the linguistic variable describes the phenomena approximately because they are complex and cannot be described in quantitative terms. It can be stated that the purpose of fuzzy logic is the same as words or phrases in a living language. The process of designing data visualization in infographics is denoted by function G. The arguments of the functions are factors of linguistic variables. Integral quality indicators are formed by function values and are determined by partial quality indicators of linguistic variables divided into groups according to their functional purpose. This process of designing data visualization in infographics is divided into two subprocesses, namely Q, which determines the quality of the artistic presentation of information, and V, which determines the quality of technical features in this process. Let's describe the linguistic variables for these attributes. For the Q argument, Q1, data visualization type, Q2, color gamut of visualization, Q3, special effects. For the V argument, V1, labels, V2, scale of elements, V3, presenting data in visualization. We establish a universal set of terms of values of isolated linguistic variables so that it in turn corresponds to the limits of the linguistic variables. The table shows a set of terms of linguistic variables values. Taking the obtained data as a basis, we build a multi-level model of the formation of integral indicators of the data visualization quality in infographics, shown in Figure 1. The use of a multi-level model of fuzzy logical derivation contributes to the consistent establishment of a forecast of the implementation of the publication structuring process quality by accumulating knowledge from the lowest to the highest of its levels. The multi-level model includes subordinate models, a model of the quality of artistic presentation of information, and a model of the quality of technical features. After that, we calculate the membership functions to the linguistic quality variables of the data visualization process in infographics. The resulting model reflects the logic of forming the quality of the data visualization process in infographics with the linguistic variables identified during the survey. The data obtained in the calculation process become the basis for constructing a fuzzy knowledge base and a system of fuzzy logical equations. On their basis, the design and calculation of the integral indicator of the quality level of research processes of platforms for the implementation of distance learning and data visualization in infographics are carried out. Next, we build a fuzzy knowledge base as well as calculate the integral indicator of the quality of the data visualization process in infographics as a function of the highest level and defined by the linguistic variable G, data visualization quality in infographics, and its linguistic terms low, medium, and high, as well as the functions of the lower level, the set of linguistic variables Q, quality of artistic presentation, and V, quality of technical presentation with their linguistic terms. In the final stage of calculations, according to the diversification of fuzzy sets and the center of the mass method, we calculate the indicator's predicted quality level of the implementation of the data visualization process in infographics. The calculation is carried out at 3 points of the interval 5, 55, and 100%, and the following numerical value is received. Based on the study, it is clear that the data visualization process is described by factors that are difficult to represent in the form of certain mathematical units. Therefore, to clarify the accuracy of the results of expert judgment, it is advisable to use such a method as the theory of fuzzy logic. When analyzing the previous results, namely using the analytic hierarchy process and the ranking method, it became necessary to use a mathematical tool with the help of which the ambiguous statements of experts would be translated into clear mathematical formulas. As research shows, the usage of fuzzy logic as a convenient solution. It provides an opportunity to operate the fuzzy input data. Based on the calculations using the theory of fuzzy logic, an indicator of the predicted level of quality of the data visualization process in infographics was established. As the results showed, it was 52.5%, which is greater than the value of 50%, which means that our assumptions and calculations were correct. Therefore, the theory of fuzzy logic helps to provide a qualitative assessment of the process research based on the calculation of the indicator of its level of predicted quality. Thank you for your attention.